Hello everyone, welcome to Math and French, lesson 6 for math. We are finally resuming our lessons again after 2 months of break, and I also want to thank all the new subscribers. The channel is slowly growing and hopefully it can continue to grow so that we can make a difference in learning. So let's get started with today's lesson. It's prime and composite numbers, divisibility, factors, and multiples. So today we're going to understand the rules for divisibility, find factors and multiples of numbers, and work with factor trees. Part 1, prime and composite numbers. So just some definitions here. A prime number is a number that is only divisible by 1 and itself. For example, 2, 3, and 5 are prime numbers because 2 is only divisible by 1 in itself. 2 divided by 2 is 1. 2 divided by 1 is 2. Composite is when a number has more than 2 factors. So for example, 48 has these many factors. And I've even color-coded them. So 1 times 48 is 48, 2 times 24 is 48, 3 times 16, 4 times 12, and 6 times 8. 0 and 1 are neither prime nor composite. So I have 2 practice questions for you. First, list all the prime numbers to 100, so that's practicing prime. And composite is identify 3 composite numbers. Make sure that they're not 48 because we already gave that, and choose 3 other numbers. And I'll also put the answers in the description box. Part 2, rules for divisibility. So when we are dividing, you can obviously use a calculator, but these are rules that say you're not supposed to use a calculator, or just for whatever reason you're not going to be using one. It's really good to know these rules because it makes the mental math faster. So for example, starting with 2, because remember 1 is not a prime nor a composite. So starting with 2, if the number is even, then that number is going to be divisible by 2. For example, 86, 248, and 5,100 are all divisible by 2 because they are even numbers. For 3, it's going to be divisible when the sum of the digits is divisible by 3. So for example, let's take a look at 96. 96, so 9 plus 6 is 15. 15 divided by 3 is 5, and so therefore, because this is a whole number, not a decimal or fraction, 96 is divisible by 3. 4 is if the 2 last digits are divisible by 4. So for example, if we have 571,648, the last 2 digits here are 48, and 48 is divisible by 4. Same thing with 24. 24 is only a 2-digit number, but that can still apply to this rule. So the 2 digits are divisible by 4, and same thing with 312. 5 is if the number ends in 0 or 5. So 35 ends with the 5, it's divisible by 5. 5,340 ends with the 0, so it is divisible by 5. And same thing with 65, 70, and 90. For 6, it's when an even number, if the number is an even number and if the sum of the digits is divisible by 3. So say 42, it's an even number, so that is a check mark. And the sum of the digits, so 4 plus 2 is 6, divided by 3 is 2. Again, 2 is a whole number, so therefore 42 is divisible by 6. For 7, it's a little more, not complicated, but it has more steps to it. So let's take a number such as 7,854. So we're going to double the last digit, meaning 4 is going to be multiplied by 2 to give us 8. Now we're going to subtract that result. So we're going to subtract 8 from the other digits, meaning 785 minus 8. And that gives us 777 divided by 7, and that's 111. So therefore, the initial number we started with, which was 7,854, that number is divisible by 7. For 8, the last 3 digits should be divisible by 8. So, for example, 40 is divisible by 8, 248 is divisible by 8, and here it's 8, and that's also divisible by 8, obviously. So 9 is sum of all the digits should be divisible by 9. So say we have 342, 3 plus 4 plus 2 is 9, divided by 9 is 1. So that number 342 is divisible by 9. Finally, for 10, the number has to end in a 0 for it to be divisible by 10. So for example, 50, 740, 90, 60, 1000, these are all numbers that are divisible by 10. And just a note that a number can be divisible by more than one number. So for example, 490 is divisible by 2 because it's an even number. It's divisible by 5 because it ends in a 0. And it's also divisible by 10 because it ends in a 0. Part 3a, factors. So factor is a number that divides into another evenly. So for example, when we have 20 divided by 4, which is 7, the 4 is a factor. Or, on the other hand, we could also have 20 divided by 7 to give us 4, and that means 7 is a factor of 28. Find the greatest common factor for the following. So let's start with the first one, 8 and 12. So you're just going to list all the factors, and to make it easier for the first one, I just color-coded them to show you why I chose those numbers. It's not really about why I chose them. It's because, for example, 1 times 8 is 8. And so again, 2 times 4 is 8. So those are also factors, and it goes up to that much. 3 times whatever will not give us 8, and so forth. If we continue going on, nothing's going to give us a product of 8. And 12, 1 times 12, 2 times 16, and 3 times 4 all give us 12. So now that I have my list, I'm going to see which number is the greatest common factor, which is 4 in this case, because there is no other greater factor in our list that is common for both numbers. And so therefore, my greatest common factor is 4. 16 and 36, I didn't color code them this time, but you get the idea of why we use these numbers. So basically 16, all the factors are here. 36, all of them are here. And out of this whole list, 4 is the greatest common factor. 10 and 18, all the factors are listed. And when I look at my list, number 2 is the greatest common factor. It appears for both numbers, and there's no other number that repeats for both of them. 14 and 28, I list them, and I see that 14 is a greatest common factor for both, so the greatest common factor is 14. And finally, we have 6 and 15 listing all our factors for both numbers. We get 3 as the greatest common factor. Next is just another method you can find the greatest common factor instead of listing them like we did in part 3a. So basically, I have an example here, factors of 12 and 14. So instead of listing them like I would in this example or these examples, I'm going to start with 12, and I'm going to see, okay, so what number could be divided by 12 or into 12? So that's going to be 2, for example. 12 divided by 2 is 6. And then I can continue going on because 6 is not a prime number. I have to end with a prime number. 6 is a composite number because not only is it divisible by itself and 1, but it's also divisible by 3. So 6 divided by 3 is 2. So 6 divided by 2, again, is going to be 3. And I could further divide 3 into itself because 3, even though 3 is a prime number, I just want to end with the very lowest one. So I could divide 3 by itself, and I get 1. And then obviously I can't divide further. Moving on to factors of 14. So 14 divided by 2 is 7. I could further divide that into itself because 7 is a prime number. 7 divided by 7 is 1, and that's what I'm left with. And now I look at both numbers, and I see that 2 is the number that is shown for both, or 2 is a factor of both. So then I come to the conclusion that the greatest common factor is 2. I could do it that way, but I could also combine the steps instead of finding the factors individually. I could put 12 and 14 beside each other, and I could say, okay, so which number would be divisible for both of them? And I would say, okay, let's start with 2. So 12 divided by 2 is 6, and 14 divided by 2 is 7. Now, 6 and 7, which number can be divided by both of them? Well, there can't really be, because 7 is a prime number, so but 6 is a composite, and so we don't have a number that's going to be able to break down 6 and 7. That's just impossible. So then I look at it and I say, okay, so what I have on the left-hand side is 2, so the greatest common factor is 2. Now some practice questions. 3 of them are done for you. We're going to go through the steps one by one to see how I got to the answer, and then the final one, you're going to be finding it out with the answer being in the description box. So let's start with A, 18 and 24. We're going to see, okay, which number could divide into both, and that's 6. So 18 divided by 6 is 3, 24 divided by 6 is 4. I can't further break or divide 3 and 4 because 3 is a prime number and 4 is a composite number. And so I look at the number I have on the left-hand side, which is 6, and so the greatest common factor of 18 and 24 is 6. Moving on, for 16 and 24, I can see that 8 can go into both. So I start with that. 16 divided by 8 is 2, and 24 divided by 8 is 3. I can't further divide 2 and 3 because they are both prime numbers. So the greatest common factor is 8. For 36, 72, and 144, yes, you can have these with more than 2 numbers. So I look at these and I say, okay, which one can go? Well, 36 can be divided into 36, 72, and 144. So I try that, and I see that 36 divided by 36 is 1, 72 divided by 36 is 2, and 144 divided by 36 is 4. I can't further divide 1, 2, and 4. So I look at the number on my left-hand side, it's 36. So the greatest common factor of these 3 numbers is 36. And for the final one, 48, 24, and 168, I've given you clues though. You have to obviously find which number goes to the very left. And when you divide 48, 24, and 168 by that number, you will get to new quotients, and you can't further divide. So that's the clue, because I didn't put more spaces for you to do your calculations. So that's the clue. For method 2, we're going to be finding the greatest common factor using only prime factors, which obviously we talked about what prime factors are, or prime numbers, or numbers that are only divisible by itself and 1. So let's say 24 and 36, I'm going to write 24 equals and 36 equals, and instead of listing all its factors of, or all of the factors of 24, I'm only going to use prime factors and multiply those to get to 24. So let's start with 2. Well, 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay, that's it. And for 36, 2 times 2 is 4, times 3 is 12, times 3 is 36. And now that I've been able to find these prime factors, I'm going to see which ones are common for both. So I have color-coded them, the oranges for 2, 2 reds, and 2 browns, or 2 browns of 3. Again, this could also, I could have highlighted it as in top bottom, so 2 and 2, 2 and 2, and then 3 and 3. Doesn't matter, just whatever way you're comfortable with. And now that I have those numbers, I'm going to put them up here. So that was 1 orange 2, 1 red 2, and 1 brown 3. So 2 times 2 times 3 is 12. Therefore, the greatest common factor of 24 and 36 is 12. For 21 and 12, pretend again this number is not here. I'm going to, for 21, list the prime factors, and it's 7 times 3, which is 21. And for 12, prime factors could be 3 times 2 is 6, times 2 is 12. And the only common factor here is 3, so I'm going to put it up here. There's nothing else. So the greatest common factor of 21 and 12 is 3. Finally, for 42 and 28, pretend these numbers are not here. For 42, the prime factors are 7 times 3, which is 21, times 2, which is 42. And for 28, 7 times 2, which is 14, times 2 is 28. And now I look at the numbers, color code them or circle them, and 7 and 7 go together, 2 and 2 go together, so 7 times 2 is 14. Therefore, the greatest common factor of 42 and 28 is 14. Here you have the opportunity to practice. I have 2 practice questions. So for 42 and 84, and again, I've given you clues. Here there's going to be 3 numbers, here there's going to be 4 numbers, and then there's going to be 3 common numbers. You're going to multiply that to find the greatest common factor, and same with B. Part 3B, multiples. So multiple is a number that can be divided by another evenly. So remember how in factors we were saying 4 and 7 are factors of 28? Well, now for a multiple, 28 is a multiple. Find the lowest common multiple, or LCM. So starting with A, it's 12 and 28. I can divide that by 4. So 12 divided by 4 is 3, and 28 divided by 4 is 7. And then I'm going to multiply 4, 7, and 3, which is going to give 84. So the lowest common multiple of 12 and 28 is 84. For B, it's 15, 6, and 24, and I want to find the lowest common multiple for those 3 numbers. Well, I can see that 3, first of all, could be divided into all of them. So 15 divided by 3, which is 5, 6 divided by 3, which is 2, and 24 divided by 3, which is 8. And now again, of course, I can't go further beyond 5, 2, and 8. So 3 times 5 times 2 times 8 is 240, which is the lowest common multiple. And for C, 10, 20, 30, 40, 10 can go into all of them. So 10 divided by 10 is 1, 20 divided by 10 is 2, 30 divided by 10 is 3, and 40 divided by 10 is 4. So now 10 times 1 times 2 times 3 times 4 is 240. And now for practice questions, try this one, and I've given you some clues. So you're going to find the greatest common factor and the lowest common multiple. And for B, here I've given you the answer. We're just going to go through it together, which can also further help you to find the answer for A. So 32 and 64, well, I can divide those by 2 to get 16 and 32. I can further divide 16 and 32 because 16 and 32 are composite numbers. And I divide them by 2 and I get 8 and 16. I could further divide those by 2, and so 4 and 8 divided by 2, 2 and 4 divided by 2, 1 and 2. I can't further divide 2 and 1 because they are prime numbers. Now, for greatest common factor, I'm going to take all the numbers that were on the left side, so 2 times 2 times 2 times 2 times 2, which is 32. Therefore, the greatest common factor of 32 and 64 is 32. And in terms of the lowest common multiple, well, I'm just going to take all the numbers that were on the left side and multiply them by 1 and 2. Well, instead of writing 2 times 2 times 2 and so on, I already found what the numbers on the left side equal to, which is 32. So I'm going to take that, and I'm going to write 32 times 1 times 2, which is 64. And our lowest common multiple for 32 and 64 is 64. For question C and D, again, I've given you the answer for C. So 77, 98, I can divide those by 7. So 77 divided by 7 is 11, and 98 divided by 7 is 14. The greatest common factor, which is a number on the left side, is 7, and the lowest common multiple is 7 times 11 times 14, which is 1078. And for D, I've given you the clues and the hints of how many numbers you're going to be looking for, and now you're going to do the rest. Again, the answer is in the description box. Part 4, last but not least, is the factor tree, and that is a diagram that helps us to see all the prime factors. So for factor tree, I haven't given you any practice questions, but I have given you examples, and factor tree is pretty easy. You can come up with any number and make a tree for it to find all the factors. So let's start with example number 1, and I've chosen the number 12. Well, 12, which 2 numbers, when multiplied, will give me 12? The first thing that comes to my head is 3 times 4. So I'm going to multiply that, and obviously gives me 12. But I can further divide 4. So I can't maybe divide 3 because it's already a prime number, but 4 is a composite number, and I can divide that further. So which 2 numbers multiplied together will give me 4? Well, 2 times 2 does. So I'm going to divide 4 into 2 branches and give them both 2's. So now the final numbers that are left at the bottom are 3, 2, and 2. And I cannot further divide those because they are all prime numbers. So here, all the prime factors of 12 are 3, 2, and 2. 45. So which two numbers give me 45? Well, 3 times 15 can give me 45. I can't further divide 3, but I can further divide 15 because it is a composite number. And which two numbers give me 15? Well, 5 times 3 does. And I cannot further divide 3, 5, and 3 because they are all prime numbers. So therefore, all the prime factors of 45 are 3, 5, and 3. And for 250, the two numbers first that can give me 250 are 2 and 125. I cannot further divide 2, but I can further divide 125 because 25 times 5 is 125. And I cannot further divide 5 because it's already a prime number, but 25 I can divide that further. And I can divide that because 5 times 5 is 25. So now the final numbers are 2, 5, 5, and 5. So therefore the prime factors of 250 are 2 and 5. So this was lesson 6. It was a longer video, but it covers all the things you need to know for prime and composite numbers, divisibility, factors, and multiples. And I like to have all of these topics in one lesson because they're all interconnected, and in my opinion, I think it's going to be the most effective when they're all together instead of separate videos and separate lessons. When we get to stuff like fractions, which is going to be in a couple of videos from now, fractions, I will further divide those because it's such a big unit that it's not going to be effective if I put all of the stuff relating to fractions in one video. It's going to be too long, and it's good that we cover fractions like part by part. But for today, this was lesson 6. Hopefully I was able to help you better understand these topics. And yeah, so thank you so much for watching, and see you in the next one.